So one thing that sometimes happens is that you have a vector v that you want to multiply by a, but once you have done that multiplication, you want to multiply it by a again, and again, and again. Okay? One way of viewing that is to say, well, I want to do the equivalent of multiplying a k times itself, and then multiplying that times our vector v. If we can diagonalize our matrix A, then we know that that's the same as x times lambda times x inverse times our vector v, raising this to the kth power. And if you think about it, if you multiply these together, the x inverse cancels the x every time. And therefore this is actually the same as x times lambda to the kth power times x inverse times v. Now, raising a diagonal matrix to the kth power is easy. That's a matter of raising each of the individual diagonal elements to the kth power. So now what you can do is, if you want to apply a to v k times, you can instead multiply v by x inverse, and then take the result of that and multiply it by lambda to the kth power, which really is a matter of taking lambda, each individual entry on the diagonal, raising it to the kth power and multiplying it times the corresponding element in the result of this right here. And then once you're done with that, you take that vector and you multiply it by x, and what you have is the net result of having applied a to the vector v k times.